There's another way that we can do part B of this problem, which is by thinking of it as a unit conversion problem. So remember, with a unit conversion problem, we are taking our $27 and we want it to be written the same amount of money, but we just want it to be written in euros. And the question is, $27 is the same as how many euros? So if you recall, when we're doing unit conversion, as long as we multiply by 1, the total amount stays the same. It's just written in a different format. So we need to think about, how do we multiply by 1 in a way that changes dollars to euros? So since I have dollars on top and I want those to go away, I'm going to try to make sure that I have dollars on the bottom so that they cancel. And since ultimately after I multiply I want there to be euros on the top, well, let's make sure that I have euros on the bottom. Okay, so those are my units, and I need to make sure that this thing that I'm multiplying has to be 1. Right? This has to be 1, or else if it's not 1, I'm changing the amount, the value of the shirt. If it's multiplying by 1, it's the same amount of the shirt, same value of the shirt. I'm just thinking of it as a different unit. So in order for this to be 1, you need to have the same amount of money on the top and the same amount of money on the bottom. So since €1 is $1.3, if I put in a 1 there and a 1.3 there, right, I get the $27 times €1 over $1.3 is going to be the total number of euros. Okay, so I'm taking $27 and multiplying by 1. So now what happens is my dollars cancel with my dollars, and I'm left with just euros as my units. And so still what I'm going to end up with is my calculation is 27 divided by 1.3 euros. So once again, that comes out to be 20.77 euros. Now, one other thing I want to point out about this problem, a lot of times people get confused as to whether, when you're trying to check your work and make sure that your number makes sense, a lot of people get confused as to whether it should cost more euros or fewer euros, right? Because some people think like, oh, well, a euro is $1.3, right? That's more money, so maybe, right, it should cost more in euros. But one way that you can think of it is any amount of currency that is not as valuable, it takes more of that currency to buy the same thing. So even if you think of it in terms of dollars and cents, right? So if you buy something for $27, it's going to cost a lot more than that in cents. It's going to cost 2,700 cents, right? A lot more when you pay in cents than if you pay in dollars. So kind of the same idea when you're going between euros and dollars, right? Since it takes $1.30 to buy a euro, think of it like that, $1.30 to buy a euro is more valuable than a dollar, which means it takes more dollars to buy the same thing as it takes euros. So it may be worth it when you have a problem like this to kind of really look at this and say, okay, what is more valuable, a dollar or a euro? And then from there, go to would it cost more dollars or would it cost more euros? And you can use that same kind of logic whenever you're doing any type of conversion, right? If you're going from feet to miles, right, a foot is smaller than a mile, so therefore it takes more feet to cover the same distance as it would in miles.